स्वयं घनश्याम
Professor M. Sharma ji, who is the chief guest of today, Aaj Hamare Beech Mein. He is an Indian chemical engineer, educated at Jodhpur, Mumbai, and Cambridge. At the age of 27, he was appointed as Professor of Chemical Engineering in Indian Institute of Chemical Technology, Mumbai. And later he became director of UBCT, first chemical engineer to do so from UBCT. Professor Sharma was bestowed with Padma Bhushan in 1987, and later in 2001 he got the prestigious Civilian High Single Award Padma Vibhushan. Dr. Sharma ji is the recipient of the prestigious Shanti Swarup Nagar Award in 1973, Vishwakarma Medal of INSA in 1985, Meghanand Saha Medal in 1994, and he has honorary Doctor of Science degree from Indian Institute of Technology, Delhi. शायद ये पन्ने कम पड़ जाएंगे और शायद पानी कम पड़ जाएगी जब प्रोफेसर शर्मा जी के बारे में हम यहाँ कहना चाहेंगे। शायद कह ही नहीं पाएंगे। And sir, we are so humbled to have you here. आप हमें पता है कि सीधे मुंबई से फ्लाइट के द्वारा आप इंदौर पहुंचे और इतनी वो जो टायरिंग जर्नी है उसके बाद में भी आपने हमारे इस एक छोटी से कॉलेज के एक छोटे से निवेदन को स्वीकारा और इन बच्चों को जो कि हमारे बड़े साइंटिस्ट हैं आपने आज आशीर्वाद देना स्वीकार किया। हम आपके आभारी हैं। इसके साथ ही I would like to invite Principal of the College, Professor Arpan Bharadwaj ji, and Head of the Chemistry Department, Professor Rajesh Parekh ji, to please welcome our guest today with floral bouquet, Soot Mala.
No, I'll get it. Should I say this? No need to.
सर ये हमारे महाविद्यालय की परंपरा है, हम सूट माला से स्वागत करते हैं, तो हम आपका स्वागत करते हैं।
Thank you, sir.
Good.
Pranam.
Guardian Suit is hereby we are just giving it to another discipline where एक और संत को ये सूट अर्पित करते हुए आज बहुत खुशी का अनुभव कर रहे हैं और इसके साथ ही मैं निवेदन करूंगी कि आप हमारे आज के अतिथि महोदय का सम्मान शॉल और श्रीफल से करें। प्राचार्य महोदय
क्यों कर रहे हो ये सब?
प्राचार्य महोदय
बच्चे को ही आना चाहेंगे।
और इसके साथ ही एक स्मृति चिन्ह मैं निवेदन करूंगी हमारे अतिथि महोदय को।
मैं कोई प्रॉब्लम नहीं।
अच्छा सर जी बस आज बच्चा एक लड़का एक बच्चा गया था। हाँ बताएं आप लोग के लिए बड़ा
थैंक यू, शुक्रिया, धन्यवाद।
मेरे बच्चे हो।
थैंक यू।
स्मृति चिन्ह देने के लिए भी मैं रिक्वेस्ट करूंगी सबको।
Oh my goodness. Thank you. I heard from Gujarat Vidyapeeth.
Yes, sir.
In Gujarat Vidyapeeth, you know, our chemistry professor from Saurashtra University was vice chancellor of this university in Ahmedabad, and they always give chakkar this Gandhi. No, not 70. I'll tell you. Shah, Professor Shah from Saurashtra University. He became Anamik Shah. They always give their Gandhi's name. Gandhi.
In the honor of Professor Sharma ji.
मैं आदरणीय प्रोफेसर शर्मा साहब का स्वागत करता हूं और हमको आज सुनना है इसलिए मैं बोलना नहीं चाहूँगा। आपका स्वागत, वंदन, अभिनंदन और आपका ये ऋण है सर इस महाविद्यालय पर और इस विद्यार्थी कुल पर कि आपके दर्शन पा सकें और आप संतों के दर्शन करने के लिए जाते हैं। मैं नाम नहीं लेना चाहूँगा लेकिन अपने अपने आदर के अनुसार हम संतों के दर्शन करते हैं। आज एक संत का नया रूप आप देख रहे हैं, जो विनम्रता है, जो सादगी है, जो अत्यंत दुर्लभ प्रण से मिलती है, अत्यंत दुर्लभ तपस्या से जो सादगी हासिल होती है, ऐसी सादगी की प्रतिमूर्ति हमारे सम्मुख है। मैं इन सब की ओर से सर आपको वंदन करता हूँ।
जिनको हम सुबह से सुनना चाहते हैं, प्रोफेसर अमित शर्मा जी को इस तरह के आशीर्वाद चाहिए।
I'm very grateful to all of you to have me here. I'm happy. I'm a lifetime teacher. The job I have done is as a university professor. Although I retired 25 years ago from service, I'm still very active, both intellectually as well as interacting with industry, chemical industry, whole range of chemical industry from petrochemicals to agrochemicals to pharmaceuticals. Uh, and I'm enjoying chemistry in its manifestations over a very, very broad range. I just want to know, you're all chemistry students? All of you? Or you have up to MSc? And do you also have some people doing PhD?
Yeah. There are students from PhD also. Yeah.
How many students are working for PhD?
Stand up, please.
They are teachers also simultaneously?
No, not
Or they are full-time PhD?
Yes. Yeah, full time.
What sort of area you work in?
Poonam?
What is your area of work for PhD? I could hear you.
नैनो कंपोजिट्स पर डाइस का डिजाइन
Photo
Oh,
category.
nanocomposites.
नैनो
You know, that prompts me to say that we deal with nano to meso. In chemical sciences and chemical industry, we make nano products, but we also make meso products. Nano products, because what has happened, since you said you are working on pigments, are when you give them in nano form, their spreading power is very high. A very common item that you use every day, your toothpaste, white toothpaste, that if you use nano calcium carbonate has a far better effect. Similarly, if you take transparent toothpaste, nano silica, and it's one of the wonders of chemistry that if I take even quartz, which is pure silica, transparent, you crush it to very fine size and use in the toothpaste, you throw it away because it is no good. So you have to convert that silica to sodium silicate and reprecipitate silica. This is all precipitated silica. And when you hear so much these days about renewable raw materials, sustainability, it so happens that we have a unique crop in India, rice. We are one of the largest producers of rice. Rice crop is the only one where the rice straw has a lot of silica. And some of you may not be aware that this silica globally is actually exploited to make precipitated silica. Precipitated silica goes in rubber industry, precipitated silica goes for whole variety of application. Toothpaste is a minor application. But tires, a lot of carbon black is going to be replaced by precipitated silica available from renewable resource to grow rice year after year. And it's amazing. That's the only crop where the rice straw is a fairly, when you burn that, you get silica. It's amazing that how crafty is nature. How does the plant pick up silica? So since you mentioned nano, it said nano today, I picked up because you said you are working on nano. But I want to give you very ancient connection in India and the most modern connection. In Ayurveda, when Swarn Bhasma prepared, it had to be nano, although that word was not used. The recipe of making Swarn Bhasma resulted in getting Swarn Bhasma in nano size. Otherwise, it doesn't act. Similarly, one of the wonders of catalysis that when you make hydrogen for a grade in fuel cell, the fuel cell is very sensitive to ppm level of carbon monoxide. And when you make hydrogen from any hydrocarbon source, whether it is methane, ethanol, methanol, you always have carbon monoxide. Now, how to reduce that carbon monoxide to less than 1 ppm, which you may start with 100 ppm. It is the nano gold catalyst which selectively converts carbon monoxide to carbon dioxide, which is harmless in the fuel cell, without touching hydrogen going to water. Now, any student of chemistry, you have 100 ppm of CO, rest hydrogen, and you are doing selective conversion of CO. Isn't it a wonder of not only catalysis? The only catalysis that works for this is nanogold. So, nano is not only byword, nano is becoming extremely important for whole range of applications, from as simple item as nano calcium carbonate to nano. All the paint that you use has titanium dioxide. And the trend is to go for finer and finer size of particles, finally leading to nano size. It's a very interesting area to work. Any other PhD student? Any other PhD student?
No, not many. It's not many.
In MSc, do you have a project, research project?
Yeah. MSc is making projects.
Who are the MSc students here? Can you raise your hand?
And sugar there, Uday, what are you doing from the top? Yeah. कुछ किया ना project तुमने?
So your MSc in chemistry is all three branches?
No, we don't have branches. It is no specialization. General chemistry.
MSc is for
MSc
general.
chemistry. Yeah.
But are there optional subjects?
Yeah, of course, subjects are there. So they read like polymer chemistry, the organometallic chemistry, and like this.
Okay.
Yeah.
But
Spectroscopy is the main thing. Medicinal is there. Medicinal chemistry is there.
and analytical.
Analytical is also there. Analytical
I want to comment something on neglected area of analytical sciences. Is anybody in analytical sciences here? Nevertheless, worth knowing. Many people think that MSc in analytical science or PhD in analytical science, that you are really serving an industry. It is not so. Some of you might have heard in the recent past that there are some drugs which are used, sartans, but sartan, the whole sartan series, some of you have a blood pressure problem taking those sartans. They found a cancerous impurity which is measured at the level of parts per billion. So you do research in analytical science, how to analyze something at parts per billion, not million. So it is no longer a service subject, it is a subject in its own rigor. Another place where, and the only time a science is used in judiciary is forensic science. And forensic science very heavily depends on chemistry. So you are now forensic university in Ahmedabad, which has now become a central institution. You remember the person who was heading that and who built that, who had a polio, Agarwal. Forensic science was judiciary. Let me tell you one or two very strong peculiarities. See, when you go for ballistics and you do the forensic analysis, you then measure lead at parts per million going to parts per billion. And the only way you can do is by neutron activation analysis. And that kind of facility is in BARC. So don't underestimate the role of chemistry, not only for quality of life. Quality of life, critically, the only branch of science which has made a great impact on quality of life. Some of you, three of you would be attending tomorrow's meeting?
Yes.
Any of the MSc students who are going to attend by any chance?
Research scholars, they will be coming tomorrow. They will be coming.
Research scholars means MSc?
No,
PhD. No, I was asking somebody to raise his hands apart from our lady member. Who else is doing PhD in chemistry?
They are not.
Huh?
They are there. Ladies are there. These two girls there.
They're not. She raised her hand, but nobody else is raising the hand.
Mostly these are
PG
PG students only. They are all PG students.
So maybe some out of this whole group, 8 to 10 people will be attending tomorrow.
Sir.
Yeah.
They are coming.
Of that all.
Sir. They are coming.
No, what I'm trying to tell you is that you might have chosen chemistry as a subject for various reasons. But I want to tell you how critical is chemistry for quality of life, for sustainability. How is food security guaranteed in India? Remember, some of you are not born when India used to import wheat from America. It was 12 PL40. Some of you will remember. And we Indians didn't like that wheat because it didn't make good chapatis, good rotis, Today we export wheat, rice. How did it happen? Partly from agriculture practices, plant breeding, hybrid, but a lot of it is because of fertilizer. So in the history of chemical sciences or chemical industry, when there is a thing called Heritage Magazine, they did an international survey and sought opinion of a lot of people as to what you consider as the most important development in the history of chemistry. What do they mention? Our wash process for ammonia.
Yes.
But for the excitement of young students, nitrogen is inert. Hydrogen is also inert, converting H2 into H, very difficult. And Haber got Nobel Prize. And the history of Nobel Prize, the engineer who got Nobel Prize was Karl Bosch. Because Haber's work could not be converted into a commercial reality without designing reactors which operated at 600 atmosphere, 500 at that time. Today we can operate it as low as 150 atmosphere. What Haber did, since chemistry is largely experimental science, there is a lot of theoretical chemistry these days, but there is no substitute for experiments, and that is the excitement, because you don't know what the result is. You predict something. So as an experimental science, there is a lot of experiment when you do. And in history of chemistry, number of breakthrough things came through what we call serendipity, accidental discoveries. You will be surprised that how many items were serendipitous. Let me give you one or two examples. All the polyethylene you use for packaging, polyethylene film, what we call low density polyethylene, was serendipitous discovery in ethylene being compressed to very high pressure for some other application. And a wax-like material came out. The engineer working on that, the ingenuity, chemist had ingenuity, and they realized a plastic is born. So LDP was accidental, serendipitous. High density polyethylene, for which Ziegler-Natta got Nobel Prize, that was also serendipitous because autoclave led to some leaching of chromium, which triggered making high density polyethylene. But I'll tell you one or two more examples which might penicillin everybody knows was serendipitous. But remember, serendipity doesn't occur to uninitiated persons. Only very observant person. Otherwise, chalo baith gaye. You have to be gifted individual to catch. Why I'm saying this? That when you do experiment and you find something very different, that might become far more important than the path you are following for your research. So let me give you one example, which is very interesting, serendipitous. You all know Teflon. On the jovial side, Teflon is one item which has gone into the vocabulary of journalists Why? They said this politician is Teflon-like, means he is most slippery fellow. So it is expression used by journalists, Teflon-like. Now, how did it come? And shows you the observation power. Tetrafluoroethylene cylinder, the DuPont scientist, Plunkett, who was doing some experiments in connection with the refrigerations. Refrigeration through hydrofluorocarbons completely revolutionized entire refrigeration industry, including what we have seen. It used to be ammonia, it used to be toxic, it used to be hazardous point of view of fire. Today, you never have a fire out of a refrigerator because the refrigerant that is used is benign. Then they discover that some are not ozone friendly, so we have new varieties of fluorine containing. So the cylinder that he was using for tetrafluoroethylene, there is a purpose in my mentioning this, particularly for young people to be observant when they are doing experiments. So in the lab, when you opened the wall, nothing came out. So many of us would have thought, oh, damn thing leaked out. So this fellow was very observant. He went back and weighed the cylinder. And it was same when it was filled. He cut open the cylinder and behold, they found the lining of Teflon. That's how Teflon was. There was a case of an Austrian husband and wife chemist team working at home doing experiments. You have all heard about cellulose nitrate. All you young ladies, your nail polish and all is based on cellulose nitrate. Cellulose nitrate also used for car, but cellulose nitrate was explosive. So, you have this wonder thing in chemical products that same product might be explosive, same product might be very, like ammonium nitrate is a good fertilizer, but ammonium nitrate is explosive. So they were doing experiments in a kitchen, and nitric acid spilled on cotton swab, and it caught fire. Cellulose nitrate was there. They were very observant, saying, repeat, found out that some very interesting reaction is taken between nitric acid and cellulose lignins. Same cellulose nitrate done when Britishers came to India, freighting of explosives. Explosives are required for mining. TNT name you would have always heard, trinitroptolone. Cellulose nitrate. So, Kharki, a place near Pune, was high explosives factory. And many of you may not know that pursuit of ammonia in the beginning, it was not originally for fertilizer. It was to make nitric acid so that you can make explosives. Explosives are not possible without nitric acid. You'll naturally ask what was the source of nitric acid before that. It was from Chile. In South America, a country called Chile, and Chile's saltpeter is a natural reserve of nitrate, sodium, potassium nitrate, mostly sodium nitrate. So you react that with sulfuric acid, nitric acid is formed. And during wartime, first wartime, this source was blocked. So how do you fight a war? So the first application of ammonia was to make nitric acid. That also is wonder of chemistry. Why it is wonder of chemistry? I'll tell you, very interesting how times change. That on a platinum rhodium gauze with a contact time of millisecond, mark my words, with contact time of millisecond, ammonia goes selectively to NO, nitric oxide. If it went to nitrogen and water, you lose your shirt. 95% plus selectivity. That NO you convert to NO2. That NO2 you absorb in water through N2O4, you get nitric acid. So the initial use of ammonia before fertilizers became important was this. And nitric acid also, because it is corrosive and origin was using this for explosives in Sweden. As you know, Sweden is very famous. Nobel was only making explosives. All the Nobel Prize season has just got over. Nobel made all his money in explosives. They had to develop a special alloy. All of you are familiar with stainless steel, but you may not be doing the original stainless steel. 316 nickel chromium. It was to handle nitric acid. So this alloy was specially developed to handle nitric acid. Now those students of, you say you have generalized course in chemistry, but in physical chemistry you hear about first order, second order, but you also remember third order reaction, right? Now student is always baffled. What is this step? Is it only a textbook curiosity that you have a third order reaction? So I am giving you a concrete example. 2 NO2 plus oxygen going to 2 NO2 is a third order reaction. What is the importance of that? So the volume of the absorber that is used to make nitric acid is inversely proportional to cube of the pressure. Was a thermomolecular third order reaction. So a large number of absorption towers in the beginning because you are doing absorption of NO2 and N2O4 in water. They look like tank farm. Then they realize that if you go to 10 atmosphere, the volume will reduce by 1,000. So huge saving in stainless steel. So it's not figment of imagination. You say molecular heat reaction. It's anything that you learn. Similarly, physical chemistry, when you take lessons in osmosis, reverse osmosis, you think it's in rice. What is this osmosis? How does it matter? Today, Pani Puri wala knows, he says, RO ka pani. Ask him what is RO. But RO ka pani hai. So how reverse osmosis led to something? That is the wonder of chemistry through polymer. That you do things which are useful. So is this PET bottle. You know how many bottles are made of different volume in the world? 70 billion. 70 billion. And India is a leading country in the world where 90% of used PET bottles are recycled. Sustainable. 90% of PET, because the reason is simple. Collection cost is small. Big airports, railway stations, hotels, so you collect majority of the PET bottle. But in experimental sciences, how diligent you have to be. You may be intelligent, but you have to be also diligent. So the gentleman in DuPont who worked on creating a composition to make PET bottle, his name was Wire. Tell you something which will be a big surprise to all of you. He had 10,000 failures. 10,000. He persisted and he used to do that in spare time. Finally, he came out with a composition which allowed PET bottles to be made. So same PET for fiber, same PET for resin, same PET for film. Isn't it wonderful? Same polypropylene for molding, same polypropylene for fiber, and a small modified version is rubber, actually polypropylene rubber. These are wonders of, chemistry means it's a wonder world. But there are some odd things I told you, bad part. That same molecule, like ammonium nitrate, cellulose nitrate. So in India, we don't allow ammonium nitrate is a damn good fertilizer because slow release nitrogen as well as fast release nitrogen comes from ammonia. And Europe and all, ammonium nitrate is a very prominent in India because it goes into the hands of terrorists, they are not allowing. But ammonium nitrate is an excellent fertilizer. So, these quirks, there are items which go for, like for example, when sulfur drugs came, they were the major breakthroughs in antibiotics. Today you don't hear about sulfur drugs. Cetron was the last important, but sulfur drugs created new revolution in therapy because they were the antibiotics. Now today you have penicillin-based, streptomycin-based, you have so many erythromycin-based and all. But original was sulfur drugs. In making sulfur drugs, you might have heard a name called a molecule called dicyclodiamide. What is the interesting history of the dicyclodiamide? How was nitrogen fixation done in earlier days? So you had limestone going to lime. Lime was in electrothermal furnace reacted with carbon to give you calcium carbide. Calcium carbide, when reacted with water, gave you acetylene. So the whole German organic chemical industry started with what was called Reppe chemistry, the most outstanding organic chemistry, Reppe, R-E-P-P-E. Everything was made from acetylene. They hydrogenated acetylene to ethylene, acetylene dimerized, made butadiene, name it. It's an extraordinary molecule. Explosive, bad. Today, major part of the Reppe chemistry is gone. Most of these things are done from ethylene now. And acetylene is used for oxyacetylene torch. But in that process, you might have heard the name of a famous American company, American Cyanamide. Cyanamide word came that if you react nitrogen with calcium carbide, you get calcium cyanamide. What is the beauty of that calcium cyanamide? It has fixed nitrogen. So when it goes to soil and comes in contact with water, it gives slow release nitrogen for the crop. And believe me, it had pesticidal value. So tobacco farms and all in America benefited a lot from putting calcium cyanamide in the feed. Why I am talking to you about calcium cyanamide? Calcium cyanamide then gave birth to dicyclodiamide. How is dicyclodiamide important? You make textile auxiliaries from that. You make explosives out of that. And you make the most famous drug for diabetes, metformin. It's pity that all metformin in India today is imported from China. Once upon a time we could have made it. See the manifestation of chemistry. Where is limestone? So let me give you finally, before then I would ask you to raise some queries. I'm very fond of giving this example of how soda ash is made. There are two parts of it. Those of you who remember college chemistry, there used to be a process called Lablanc process. So you reduce with coke, sodium sulfate to Na2S. And aqueous solution of Na2S, you carbonate, pass carbon dioxide from the flue gas when you burn the fuel. That led to making, and that was washing soda. That was the only detergent in the early years. And soda bicarb was baking soda. See, it's funny. Sodium carbonate is detergent. We used to make glass and all. But soda bicarb is food. All bakery uses soda bicarb and produce them in hundreds of tons per day. So this emitted H2S, who is a smell of rotten eggs when you do Gibbs apparatus. So this was first example in the world. How early? In 1840s. So Britain used to have an office before, Department of Environmental Sciences, Pollution Board was created. His Majesty's Alkali Inspector. The first recorded example in history when he ordered the closure of this plant, saying you get egg, rotten egg smell few miles before the factory. So, today you talk of factories being closed, but I am giving you an example of 1840s, late 1840s. Out of that was born Solvay Process for soda ash, whose name company exists today. The man with the genius, Ernest Solvay. Now, Solvay is a huge chemical industry, Belgium-based, but it has base all, including units in India. What a wonder it is that you react sodium chloride, the most inert material which has remained for millions of years, calcium carbonate, limestone, which has remained for millions of years. So if you write down a simple equation, 2 NaCl plus CaCO3, Na2CO3, it looks delightfully simple. But there is no way you can react sodium chloride with calcium carbonate. Both are inert, thermodynamically impossible. Then you raise up, how is it done? So it is done by a trick. That you ammoniate brine solution, pass carbon dioxide, and then soda bicarb precipitates, which you can sign and soda. How ingenious! That you made two inert substances react, which would have never reacted. Mind you, this was done well before synthetic ammonia was born. So you will ask, what was the source of ammonia? Including for the Karki factory, from steel plants. The coke oven gas contains ammonia. And that was scrubbed with sulfuric acid. And that ammonium sulfate you reacted with lime to get ammonia. It looked like quack today. But that's how it was done. So, there's a lot of fun. There is excitement. There are challenges. Chemistry is a delightful subject. So you are doing chemistry, I encourage you to pursue to its best level. And you will find it very rewarding. Apart from its utility in life, whether it is health, whether it is sanitation, anything. Today you see what happened during the time of COVID. What protected you? How much was the consumption of isopropanol and ethanol sanitizing? How much plastic was used? COVID showed extraordinary application of chemical science. So apart from its utility, it is a very exciting subject. Whether it is catalysis, whether it is polymers, whether it is for pharmaceuticals. But my brief discussion which will be incomplete if I did cover one very important point which changed the health system throughout the world, and that was PIL, the Jersey, family planning PIL, all gift of chemical science. Imagine if the pill had not come, what would have been the global population? It is extraordinary impact on quality of life. So you see for yourself the beauty of chemical science, the challenges in chemistry. If you read the history of people who get recently, you heard how Nobel Prize for the second time came to Sharpless click chemistry. But his first Nobel Prize was on asymmetric epoxidation of ethyl alcohol. The first example of asymmetric synthesis was hydrogenation to make a very famous drug L-Dopa for Parkinson's disease. Today we make one agrochemical whose commercial name is Dual-Magni at 20,000 tons per annum using asymmetric synthesis based on iridium. Similarly, we had major breakthrough which led to Nobel Prize metathesis. What is metathesis? Chopping and stitching of molecules, dancing on molecules. How did it start? It started in industry when propylene was in large surplus. Today, propylene price is more than ethylene. So if you took 2 moles of propylene, you chop, you make ethylene and butene. We do exactly ulta of that. We make far more protein because a lot of butene 2 is available, and we do metathesis with ethylene. You know, Nobel Prize went for metathesis. And this metathesis today is used in polymer, in the drug, agrochemical, is an extraordinary. But imagine, isn't it a wonder of chemistry that you chop a molecule and stitch? You have chop a double bond and then stitch, it doesn't go waste. Really charming, extraordinary. So enjoy chemistry. It's a wonderful subject. My job is to take chemistry to
The students need
vaccine निकाल
This is a newsletter.
all in Hindi,
All in English.
all in English.
Yes.
I can read it. I don't have it.
So I would just like to mention this magazine का newsletter का जो खासियत है वो ये basically the data being collected from different sources, but this is based on which you are talking just about that how the chemistry is useful and how it can be utilized in area this. This is also catering to SDG 13, that is climate action. How the chemistry is catering to climate action, how we are just painting to air pollution and all that. ये मैगजीन उसके बारे में है तो सर आप इसको पब्लिश करें इन स्टूडेंट्स के लिए या आप स्टूडेंट्स को who are the student editors of इसके काम किया है I would like to invite Anshu Pandya, Aditya Singh, Uday Singh Chauhan, Neha and Riya Yadav to please come and get this message published from the hands of.
See, everybody is talking of sustainability, circular economy. Chemistry has a very major role to play. All CO2 abatement, how you, all chemistry triumphs. Yes, it triumphs.
and clients.
What is the best example I can give you of a liability to a huge asset? Crude oil production, sour natural gas field H2S used to come, used to burn and emit, create horrible atmosphere. All H2S is recovered and converted to sulfur today cross process. Entire available amount of sulfur in the world is from H2S recovered to hydrodesulfurization. So if you take crude oil production of and gas 5 billion tons per annum and 1% sulfur in that, how much sulfur will you recover? So people forget many things. You know, people only talk about some explosion that took place or chlorine leak and all that, not realizing good. So it shows the role of chemistry in climate change because remember, I gave you example of refrigerants and that there was a major breakthrough till they found they were ozone unfriendly. Then they developed ozone friendly. That's the promise of chemistry. Not like it. No. Good.
All this is
It's a monthly newsletter.
Dr. Kalpana Singh is doing that.
Dr. Kalpana Singh is the
Yeah, that is how you encourage.
students. This novel.
I know.
So the students are very outstanding.
You must ask them to write an essay on click chemistry.
That's
Very interesting. You know.
click chemistry.
Click
How
chemistry.
to react
Sir,
to
sir, we have invited essays on click chemistry. We'll be submitting, sir. आज इनका एक सर हमने extempore test भी दिया है. That
अच्छा.
is on click chemistry and bio orthogonal reactions.
Very good, very good, very good.
हाँ,
हाँ, ओके.
that will become.
ऐसी तरह से आप वो दीजिए सुजुकी कपलिंग, है ना?
अच्छा
क्या खाली साइन करूँ?
सर ये हमारे लिए बहुत बड़ा असर होगा सर।
बच्चे के लिए. Today is 12th.
12, 10.
ठीक है
Thank you, sir. Thank you.
बच्चे सर they want to
सर बच्चे क्योंकि मान गए हैं टीचर वाले
हाँ यस यस सारे कॉपीज करवाने जितने प्रिंटेड आज सर हमारी got it result with us. This is part of a treasury now. It's not a news that it is space of treasury.
Ravi sir,
See, when you are saying maths and chemistry is fun, all your enjoyment, all the Diwali patakas, what are they?
chemistry.
Huh?
They're all chemistry.
Road flares for defense.
Sir, you have to go to Bangladesh and then Sayaji and say,
Okay.
I'm getting late.
No, I'm okay.
Sir, I would just request you Pradesh to accept this from common rule.
Thank you. Respected Professor Ravi Sharma sir, the living legend, and really thank you for accepting our invitation to come to our college campus. And really, you are supposed to be tomorrow at actually Vaishnav University as a chief guest. But with the inspiration of our principal Professor Arpan Bharadwaj, I spoke to you, I requested you, and I really also delighted to have you here today, sir. Thank you very much. And you are a living legend. You are a motivation and inspiration to all of us. Thank you very much, sir.
बच्चे जरा दौड़ के सीढ़ी पे खड़े जाइए फोटो के लिए सर की जगह रखिएगा आप दौड़ के जाइए फोटो के लिए खड़े जाइए
ये पैनल
बच्चे 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 दौड़ो दौड़ के जरा खड़े हो जाओ सर के साथ फोटो लेंगे
ये पैनल बाहर
दो बैचेस जल्दी दौड़ के बाहर खड़े हो सीढ़ियों पर
I'm okay.